Scientists once discovered radiation from across the cosmos while they were cleaning up pigeon poop. In the late 1950s, Bell Labs began building the Holmdel Horn Antenna, a 20-foot-tall horn rising out of the New Jersey countryside in Holmdel. Its job was to catch radio signals bounced off of NASA's reflective balloons, a program called Project Echo, one of NASA's major communication experiments, built around an audacious idea, sending messages by bouncing radio waves off giant aluminized balloons placed in orbit. In 1961, a radio astronomer named Arno Penzias, a refugee who had fled Nazi Germany, joined Bell Labs to upgrade that antenna with a maser amplifier, a receiver that, once supercooled, would become the quietest radio receiver on Earth. To catch the faintest signal reflected off of the balloon in orbit, the system had to be almost perfectly silent, and that meant driving down its own noise. The biggest culprit was thermal noise, so the team at Bell Labs, Penzias among them, chilled the receiver with liquid helium to 269 degrees below 0 Celsius, or 4 Kelvin, just barely above absolute zero. With the upgrade complete, Penzias, joined in 1963 by his partner, Robert Wilson, was given the antenna to continue his work in radio astronomy, the branch of astronomy that studies the heavens, not through light, but through radio waves. It was a field Bell Labs had practically founded back in the 1930s. Its researchers had discovered radiation streaming in from the Milky Way itself. But the same supercooling that let the antenna hear faint communication signals had a side effect. It also made the receiver extra sensitive to other kinds of radiation, including the faint radiation drifting in from distant celestial objects. A star or a galaxy might pour out enormous amounts of radiation, but across the vastness of space, and everything in between, that signal grows weak until it's nearly lost in the noise created by the temperature of the local surroundings. With a receiver this quiet, those faint signals could finally come through. And, as the two scientists turned the antenna on the sky, they noticed something peculiar. A persistent hiss measured at 3.5 Kelvin and later refined to 2 725 thousandths. It was there no matter which direction they pointed. Certain the noise had to be coming from something local, they began the painstaking process of ruling out every possible source. The glow of nearby New York City, fallout from recent atmospheric nuclear tests, even radiation from the Van Allen belts, charged energetic particles thrown off by the solar wind. One by one, every explanation fell away. Finally, convinced something was wrong with the installation itself, they tore the horn down and rebuilt it. That's when they found it, what Penzias dryly called a white dielectric material. 2 pigeons had nested inside the antenna and coated its throat in droppings. They removed the birds, scrubbed the antenna array clean, powered the horn back on, and the hiss remained. Out of answers in his own lab, Penzias turned to established research. In a conversation with his friend Bernard Burke, an MIT physicist, Burke pointed him toward an unpublished preprint by Jim Peebles, a theorist at Princeton. Peebles was working with physicist Robert Dicke, whose group was studying this exact kind of radiation. And the paper predicted precisely what Penzias had been measuring. So Penzias called Dicke and walked him through his numbers. Dicke hung up the phone, turned to his team and said, "Boys, we've been scooped." And in truth, they'd all been beaten to it long before. Ralph Alpher and Robert Herman had predicted a cosmic radiation 16 years earlier, but their idea never gained traction and was never put to the test. What Penzias and Wilson had spent so long trying to silence was a signal coming from the universe itself, something we now call the cosmic microwave background, a discovery that would earn them the 1978 Nobel Prize. It was something built into the very way the universe was built, something that, no matter how hard the scientists tried, would always be there, and always will be. The universe was glowing.